So in our yesterday's session, we have done lots of things regarding encryption, right? So I have shown you my Windows 10 machine, and we have elaborated lots of things: how to encrypt single file or folder, how to encrypt entire drive, removable drive, or and some sort of thing. Okay, so that we have seen in our yesterday's session. So now I'm going to start with our KMS service. Now this KMS is AWS service, and it stands for Key Management Service. Okay, what is the long form of KMS? It stands for Key Management Service. Now what that key is? What that key is? The key is used to encrypt and decrypt your data. So when you are going to create any data with AWS, definitely you will need to encrypt it. See, AWS will never encrypt your data. They are providing you all the tools and services. It is your responsibility to encrypt your data. Okay, so now if I have created some data, maybe in my S3 bucket, this is my S3 bucket, and I have put some object into my S3 bucket, and I want to secure those objects. Okay, so secure, when I want to secure it, definitely I will go for encryption. So I will need encryption key. Okay, I will need encryption key, maybe symmetric or symmetric. Okay, so who is going to provide that key to me? It is the key management service. So that is what we are going to do. We are going to see how encryption is going to work with this key management service. So in our yesterday's session, we have seen different terminologies. What do you mean by plain text, right? That we have seen. What do you mean by ciphertext? And what do you mean by key? Okay, so conversion of plain text to ciphertext is known as encryption. And to achieve that, we use something which is known as encryption key. Okay, so this key can be symmetric or asymmetric. If it is a symmetric key, it is also known as secret key cryptography. Okay, so what is there in symmetric key? The sender and the receiver are going to use the same key. It is very fast. Yesterday we have seen the differences. It is very fast. The only problem with symmetric key cryptography is how to share this key with the receiver, right? And there we have seen yesterday how the hybrid encryption comes there. Okay, symmetric key, asymmetric key, as well as hybrid. So what actually is happening? The sender is creating one key. What exactly was the hybrid encryption? The sender was creating one key. Okay, and now how to securely send it to the receiver? How to securely send it to the receiver? For that, what he was doing? He was encrypting this key using the receiver's public key. Okay. So initially, probably he has encrypted some data, but which key he has used to encrypt it? This key. Okay. So now he is the sender, and he needs to send this key to the receiver. So how securely he is going to send it? He will encrypt that key using the public key of receiver. So now this file will go to the receiver, and this will again go to the receiver. To open this file, the receiver will need the key. But where is the key? It is in this envelope, right? But to open this envelope, the receiver will use his own private key. And that private key belongs to the receiver himself, right? Nobody else has that private key. And see, we are achieving this confidentiality, that nobody should have access to this key. If anybody gets access to this key, they will be able to retrieve the data, right? But now who is the only person who will be having access to that key? The receiver, because it is been encrypted using receiver's public key. So the receiver will use his private key to open it, and then he will decrypt the data. Okay, so this is what we have seen in our yesterday's session. And this is known as, sometimes it is known as envelope encryption, sometimes it is known as hybrid encryption, something. Okay, so I will elaborate one scenario today. I will create two users, maybe Alice and Bob. And we will elaborate a scenario that Alice wants to send some data to Bob. Okay. And for that, Alice will be using a key, encryption key. And for that, she will be using the key management service. Okay. So this is what we are going to do. Now, when we go to our key management service, let me simply create two users first. Okay. We will go step by step. So I will first go to my identity and access management. I'll go to user. Okay, let me delete this user. I'm already having that. Or we will elaborate some different scenario altogether. Okay, I will tell you what I'm going to do. But let me create two users. Anyway, I need to create two users. Right now, I will not give any permission to Alice. Let me create one more user. Again, without any permission, without adding that user any group, I have simply created two users. That's all. Now, when we go to this key management service, okay, I will go to this key management service now. So in key management service, we are going to create something which is known as customer manage key. Okay, CMK. So we are going to create our customer manage key. Now, for the time being, just assume that in your organization, you have created this customer manage key. Now I'm a root user. I can even create that. Okay, so no problem. I will use my root user. I have already logged on with my root user. I will go to my root user and I will create that customer manage key. But now when I am going to create this customer manage key, I will give some permission to Alice. I can give some permission to Bob. So for Alice, probably, maybe I want to give administrator permission. But for what? For what? Only for this key. So what it means now, Alice will be able to do some administrative task on this key. She will even be able to delete that. Okay, with the administrative permission, Alice will be. So say two types of permissions are there with the customer manage key. Admin permission as well as user permission. Okay, so this is also known as key uses permission. So to Bob, I will give key uses permission. Now what exactly is the difference? Bob will not be able to delete that key, but Bob will be able to use that key to encrypt the data. What the difference, everybody? So what is the difference between admin level permission and the key user permission in our KMS? Okay, so we will do that. Let me go to my key management service, KMS. Okay. So there are two types of keys, as you can see. AWS managed key. Now these are already created by AWS. Okay. So where have we seen this key? Let me show you. We have seen that key as well. So when I go to my S3 bucket, let us say, and let us say there is one bucket, I want to encrypt that bucket. Okay. I want to, let me create one. Name already exists. Okay. So this is the bucket I have just created. Okay, SEMA 2020. So if I go to this bucket and if I go to properties here you can see default encryption. Okay, so if I just click edit here, see server side encryption with Amazon S3 manage. Amazon S3 managed key. Okay. So what exactly happened, you know? So when I have created that bucket, automatically it got encrypted. But which key AWS has used for that? It has used Amazon S3 managed. Okay. But there is one option. I can use AWS Key Management Service Generated Key, KMS. Okay, so choose from your AWS Key Management keys or enter AWS Key Management Key ARM. So I don't have any key right now. Okay, I don't have any key created. This is, I guess, I think I have created one before. Okay, I don't have any idea. Definitely, I had created it, but whether it is active or not, I don't have any idea. Okay, so either you can select your key directly or you can specify the ARN of that key. Now, instead, AWS is using this key for encryption. Now, see, who is managing this key? AWS is managing this key. And if your compliance doesn't want that some cloud service provider should manage your encryption key, right? So in that case, you are free to create your own customer managed key. So how are you going to create it? Using the key management service. Got the difference between this? So this is what we can do. So anyways, that bucket is already been encrypted. Okay, so nowadays we cannot create the bucket without encryption. It is already enabled. Bucket key, it is already been created. Okay, server-side encryption with Amazon S3 managed key is already been enabled there. Initially, it was not there. Okay, we need to do it manually. But now, because it is with Amazon S3 managed key, if I want, I can use my own customer managed key. Okay, so later on, we can use the customer managed key and we can change this encryption. Okay, so for that, let me KMS console and let me click the option create key. Now, which key? Definitely it is customer managed key. Which key I am going to create? Symmetric or asymmetric? Okay, so I want to go for symmetric, a single key used for encrypting and decrypting the data or generating and verify your HMAC code. Fine. Even asymmetric can be created. A public and private key pair used for encrypting and decrypting the data or even for digitally signing your messages. So these are the use cases, folks. Okay. So public key and private key are not just used for encryption, but they are also used for digital signing. And yesterday we have seen it very clearly what exactly we mean by digital signing. So let us make it simple. So let me go for symmetric key and what is the purpose of the key? For what purpose I am going to use that key? I will be using it for encryption and decryption of my data. Okay. There are some advanced options. Let us use the recommended one. Okay. And I'm going to create a single region key now. So what is the difference single region key? So if I create single region key, it will just be applicable in my Oregon region. I will not be able to use that key to encrypt the data which will be creating in my maybe Singapore region, Mumbai region, any other region. Okay, so let me just restrict myself to single region. Next. Now it is going to ask me alias. Now alias is nothing but the name of your key. So let me give some key. Let us say my test key. Okay. Description is optional. So let me not give it. So tag, let me tag it. So let us say name. And it is my test key. Next. Now see, it is asking me key administrator. Now, who will be the administrator for this key? As we have already decided earlier, I want to make Alice as the key administrator. I can select any user and not necessary that I have to select it right now. Later on also, when everything has been done, if I want to change the key administrator and I want to add some administrator or want to add some user for encrypt, so that they will be able to encrypt it, even that can be done. Okay. So for the time being, let me select Alice here. Now I will select the option allow key administrators to delete this key as well. Next. Now it is going to ask me key uses. Yeah, key users. Who will be the key users? To whom you are going to give permission to use this key to encrypt and decrypt their data. Okay, so let me give this permission to Bob. Next. You cannot change the key configuration after the key is created. But which configuration? This one. I will not be able to change the key from symmetric to asymmetric. Okay. I will not be able to change the regionality. I will not be able to change some specifications regarding the key. Okay. Even the uses. But I will be able to change the administrator and the key users definitely. Okay. So now if I just go to this key policy, okay, let us see the permissions which are associated with this. Okay, now see, this is for the user Alice. Now what Alice can do? Alice is having lots of permission: create, describe, enable, list, put, update, so forth. Okay. And for Bob, user Bob is having limited permission. See, he is not able to delete that key, right? He will be able to encrypt, decrypt, re-encrypt something. Okay, but he'll not be able to delete that key. Okay. Let me click finish now. Now this key is getting created. It is created rather. So see, I can be, and as I already told you, now I will be able to change this part. If I want to change key administrator, I can do that. I can add some other people to become administrator maybe, right? And I can change this permission and key users. Even right now just Bob is there, but let us say if I want to add some other user as well for key use, okay, so I can do that as well. So this is how it works. Okay, now let me tell you one important. We cannot use console for this service. Okay. So to encrypt the data, to decrypt the data, everything has to be done using command line. Okay. So console, we will not be able to use here. Okay. So that is it. If you remember, when I had elaborated the differences between GUI as well as command line interface, right? So GUI is our console. I have told you that most of the time CLI is preferred, but sometimes it is mandatory to use the CLI. Okay, what is the reason? Because some tasks cannot be done using the graphical user interface. And yes, encryption and decryption is one of the tasks. Okay, so now what I will do, I will, so see folks, I can definitely use Alice for that. Okay, but I have already having my user credentials inserted. Let me check. If I go to the command prompt now, and if I give the command AWS configure, I can see one ID is there. Okay, let me see which ID is there. I guess let me use this ID. Okay, so I will use this ID. Secret key. So this is the credential of the user having administrative permissions. Let me select US West 2 as the region. Default format is JSON and that's all. Okay. Let us quickly check whether this user is really having the permission. So if I use the command AWS S3 MB S3 colon double slash, maybe bucket name I will give And yes, the user is having the appropriate permission. So he is having full control permission. Uh, I know it. Let us verify it once again. Okay. So let me just want to make sure that the user is really the administrator user and not just the user with S3 full access permission. So if I go here, permission, you can see administrator access. So instead of using Alice, I can very well use this user. So I have already authenticated myself over here. Now, folks, what I will do, I am going to use the key to encrypt the data. To make my job easy, what I will do, I will go to this location, C user SEMA, and I will create one notepad, one text file here that I will be using to encrypt. See, I can create it anywhere. Even I can create it on my desktop or something, right? Even I can go to the EC2 instance and I can create that data on that. Okay, but to make it a little bit easy, what I will do, I will create it in this location, one notepad file. Let me go to my C drive. And let us assume that this is my confidential data. Okay. So I will be encrypting this data letter. Purposely, I have created it here. The name of my file is demo. Okay. So I will be encrypting this file. Where it is created? It is created in C, users and SEMA directory. Why I have selected that? Because by default, my command prompt is going to be at that place. Okay. So I need to define the path of that file in that. Okay, now what I will do, I will go to help you, because see, here we are going to use the commands, and remembering command is always a difficult task, right? So I will take you to the documentation, AWS CLI, maybe documentation. Let me see. Okay, let me change my search. Okay. So see, this is going to give me all the information. I usually use this documentation. It is very, very helpful indeed. So if I scroll down here, you will see all the available commands. So you can cancel key deletion, connect, create alias, create key, decrypt, right? Even encrypt. So initially we are going to encrypt. We are going to use the commands related to encryption, right? So we will be using it. But before that, even before that, what I will do, I will go to the command list keys. See, list keys. So it is going to show me what the keys are there in my account. So if I go here, the command is AWS KMS list keys. So your command will always start with this AWS KMS. Okay. AWS KMS. And on top of it, I will use option list keys. Now, whatever has been mentioned in this square bracket is optional. Okay. All these are the optional one. These are not the mandatory. So probably they must have given one example here. Let us scroll down. Yes, the command is AWS KMS list kit. Now let me use this command. So it will show me all the keys which are there in my account. Now see, all these are not definitely customer managed keys, because customer managed key I have created right now in front of you. but these are the AWS managed keys. So probably I have used it for encrypting my bucket, my elastic block storage, my DynamoDB, and whatnot. There are lots of services where we can use this encryption. Just to recall, if we create our EC2 instance, okay, so see, this is again very important. So if I just go to the EC2 service here, see, if I launch the EC2 instance, let me select Linux 2. Let it be in default VPC, everything I want as default. And now see, this is the 8 GB root volume, but it is showing me not encrypted. Now, if I go to the advanced option here, and if I select that encryption, okay, I want it to be encrypted, then it is asking me to select the KMS. Okay, so I have to select either the AWS managed key. All the AWS managed keys will start with this AWS slash. Okay. So if at all you see any key with this AWS slash, it means that these are the AWS managed key. But now you can see my test key is also. I can use this key to encrypt this EPS1. What it? So keys, you can use it for multiple services. Let me not encrypt it for the time being. Okay. And let me just launch it. Even I don't need it right now, but let it be created. We can use it in some other scenarios. So this is how we can use that key not only to encrypt our S3, but it can be used at multiple places. If I want to encrypt my elastic block storage, I can use the key which I have created. Okay. So just now we have run the command AWS KMS list keys, and it is showing me all the keys. And it is also showing me ARN of the key. Now what we will do, we will go to our KMS service first. And what is the ARN of my test key? So this is the test key which I have just created. Okay, my test key. And its ARN, it is a big name, but it is ending with EC6 something. I can see it from here as well. ARN. Where is my key? E6C, right? This is the key which we have just created, 4EC6. Let us verify it once. Four EC6, right? So this is the key it has listed here. It's fine. So this was the least key option. Now we want to encrypt our data. So for that, let us go to the documentation once again. And now let us search the command which is going to help me in encryption. Okay, so we will go for encrypt option. Again, this command will start with AWS KMS encrypt. Okay, the command will be AWS KMS encrypt. And then we can see what options are available. Symmetric key, asymmetric key. We can select all these options. Okay, so see. Encrypt, AWS KMS encrypt, hyphen key ID. Now, this is mandatory. Okay, so it is not in that bracket. It is mandatory. And then I have to provide the plain text, right? So for that, I have already created one demo file in my C users CMA directory, right? So I have to provide the key ID and I have to provide that plain text. But for that plain text, I have already created a file. So I have to provide the path of that file. Okay. So I will not simply give the letters or words here. I will provide the path of that entire file. Now, how to get your key ID? So this is not the ARN basically. So how to get your key ID? If you go here, just hold on, let us go to that key. Okay, anyway, what we will do in my command itself, if I go to that one, it is showing me this is my key ID. Okay, so what I will do, let me copy. This is my key ID. Definitely, I will get it from that console as well, but I am not able to see it. So let me just copy this, and for my convenience, see folks, if it is a command, now especially this one will take little bit time. Okay, so just hold on. We are going to do it step by step clearly so that you will not find it at all difficult. So what I will do now, this is my key ID. Where I have copied it from? I have copied it from here. It is ending with again this 4EC6. Okay, but this is the ARN. 4EC6. Yes, 4EC6. And now this is the command. AWS KMS encrypt hyphen key ID, and I have to give the key ID. Now instead of this, I will be using this key ID. And then hyphen plain text file B, that is the blob, and then I'm going to give the name of my file. Okay, so let me change this command accordingly. So what I will do, I will just copy this ARN or key ID and let me replace it in this command. First thing. And second thing, hyphen plain text file B, and now name of my file is demo. Okay, so now this is the command I will be using. So let me copy this command. Let me go to my command prompt. I could have used Bob here now, okay? Because Bob is having the appropriate permission to encrypt the data. Fine. And one more thing, because my key is region specific, okay? So what I will do, I will give the option hyphen region here. And that is west. Got it, folks? So what I did, you understood this command, what I'm exactly doing? And now let me end. I think it is plain dash text. What is the problem? There could be some syntax error here. Okay, let me go to the documentation. If you are finding some error, what if at all you are getting what I'm doing wrong, please let me know. No, it is plain text only. It is not dash. Let me go to the example. Yeah, but it is the one. Okay. Let me try to use once. Okay. I don't know where I did wrong. Probably this is the only change I did. I have given quote here. Okay. But anyway, now see. Now it has encrypted my file. Okay. And this is the cipher blob it has given to me. This is the cipher blob. Now, if this is encoded in base 64 format. Okay. This is encoded in, by default, it is going to get encoded in base 64 format. Now I want to remove that 64 base 64 encode. I will just go to any website. I don't have any tool right now. Let me go to Google and let me just search for base 64 decode. Okay, so I will go to this website. You can go to any website rather. So see, I will first remove that code. Let me just go for the command, and this is the. Okay. So this is the one. I hope I have copied it correctly. AQ and ending with some 2 equal to sign, right? Fine. Now, if I decode this, this is actually the encrypted version of my text, of which, of that demo file. Hello. I think I have just written hello there, right? So this is actually the encryption. Initially, this was just coded with this base 64 encoder. So I have decoded that. And in that, I have seen this is my encrypted message. This is definitely not the decrypted one. This is the encryption. Okay. So now let us do it in the reverse way. Now I want to decrypt my message, right? I want to decrypt my message. Now how I am going to do that? Again, I will go to, let me first go to the documentation. Let us see the command. So if you go to, okay. So here I will go for decryption this time. I'm doing it slowly. The reason is that you are going to perform it in your lab. Okay, you should understand what exactly we are doing. So if I go to decrypt option here, now again the command will be AWS KMS decrypt and all other option. Let us see what are the essential option. The essential option is decrypt and hyphen cipher text blob. Now this is the cipher text blob I have to provide. And if you go to command, this is the cipher text blob. Okay. So which I have already copied it in this decoder's website. This is the one it is going to ask. Okay. So this is my cipher text blob. So what will be my command now? I think I have already written that command here. AWS KMS decrypt hyphen cipher text blob. And here, because see, I have used the same word hello here probably. It is giving me the same one. Okay. So this is the command. Let me use this command. AWS KMS decrypt cipher text blob, and this is the blob. Let me see whether it needs the quotes as well. Fine. It is done. But now see, again, it is showing me this is my plain text. But again, it doesn't make much sense, right? It is not making any sense to me. The reason again, it is coded in base 64 format. So what I will do now, I will copy this again. So see, because it is Windows machine, I need to do this one. If it is Linux or Mac machine, then automatically it will happen. Okay. So let me go to that website once again. And this time what I will do, I want to decode this. I will click the option decode. And now you can see it is showing me. Okay, folks. So see, this is what the AWS AMS encryption, how it works. Now, if I take you to the lab, which we are supposed to perform in our console, let me take you there. Data security, and the lab is 278. Now see what you are going to do. First, overview. Cryptography is the conversion of communicated information into secret code that keeps the information confidential and private. Functions include authentication, data integrity, and non-repudiation. The central function of cryptography is encryption, which transforms data into unreadable form. Encryption ensures privacy by keeping the information hidden from people who the information is not intended for. Decryption, the opposite of encryption, transforms encrypted data back into data. It won't make any sense until it has been properly decrypted. In this lab, you will connect to a file server that is hosted on an Amazon Elastic Compute Cloud. Now, folks, see, you will already be getting one EC2 instance created, and that EC2 instance is the file server. File server in the sense it is holding your files. You will configure the AWS encryption command line interface on the instance. You will create an encryption key by using the AWS KMS service. The key will be used to encrypt and decrypt the data. Next, you will create multiple text files that are unencrypted by default. You will then use the KMS key to encrypt the file and weave them while they are encrypted. You will finish the lab by decrypting the same files and weaving. So in short, you are having a EC2 instance. On that EC2 instance, you will be creating a bunch of files, okay? And those files you are going to encrypt first using the KMS, but before using KMS, you will be creating your customer managed key, okay? And once it is done, you are again going to decrypt. So instead of using your computer, the way I have used here, okay, what I have done, I have created that file onto my C user CMA directory. So instead of that, in this lab, you will be using the EC2 instance, which they have already created for. Okay. And it is going to take 45 minutes. So the first task will be create AWS KMS key. And again, you are going to create symmetric key the way I have shown you. You are going to give some alias for that, a define key administrator. Okay. And even the uses permission, and configure the file server instance. Now see, this is something which I have not shown you. Now see folks, what they are doing here. They are installing the CLI for encryption. I have not done that. What I have done, actually, I have used the normal command line interface, which we can use for various purposes. Okay. So I have not used the special command line interface, which is just used to go for the encryption. Okay. Which is just used for the encryption. But here in this lab, you are going to, I guess, going to do that. Okay. So otherwise, see, AWS configure command is there. Access key, secret key, you are going to give region. Okay. And fine. Okay. Encrypt and decrypt the data. Okay, fine. So now you are going to use the touch command and you are going to create secret 1, secret 2, secret 3 and echo top secret in secret 1 file. Then you are going to use cat mkdir output. So copy and paste the following command to a text editor. So you are going to use this command on your text editor. So later on, you are going to actually create your own command. So here, what is the difference? Here they have used AWS encryption CLI. Okay. So what I have done, I have simply used the command AWS KMS encrypt. Okay. But here they have used this command prompt. Okay. So this is the only difference. So you are just going to follow what they have asked to do. Okay, so here you are going to do the same. So this is the symmetric key. And again, they have used this command line interface. And that's all. Okay. So I hope this lab now you will be able to perform. Now today, I want you to send me the screenshot as well. Once you are done, I want the output of your this one. I want you to send me the screenshot of this 43 command, but that will be the final command, right? So that will be the final command. Once your secret 1 file is encrypted and decrypted, so I want to see the output. Okay, so this is what you are going to do once you are done. Will it be fine, folks? Will it be possible for you to perform this lab? Just don't ignore this lab. It is very important. Any question? So please note it down. I want you to send me the screenshot of 43rd step of this lab, 278 lab. Okay, now let me proceed. So we have done with this one. And now I will start with this public key infrastructure. A little bit theoretical only because we don't have much here to demonstrate and something, okay? So you just need to understand this. Okay, let us start. PKI, public key infrastructure. So it will be easy for you to understand this now, rather. So here, what is the objective? You are going to see how the public key infrastructure works and describes its major components, how certificates works, and how they can be used to secure information. Describe certification authorities and their common configuration. So public key infrastructure. Let us begin. So we are at the prevention state, and now we are a prevention phase of the security life cycle, and we are at public key infrastructure. So see folks, so these are very important to understand. What comes in a prevention phase of security life cycle? Network discovery, system hardening, system security architecture, network hardening, then data security, public key infrastructure, as well as identity management. So these are the components of your prevention phase of security life cycle. Okay, long way to go. We have not yet started with detection, response, analysis. Okay, so long way to go. Anyway, let us proceed. Now I think we have already seen how you are going to trust the banking website, right? So first of all, you will see your website's certificate. So again, if I take you to any website, let us say I want to go to facebook.com. So here you can see this padlock. So if I go here, it is showing me my connection is secure, right? And if I just go to certification, certificate is valid option, it is going to show me who is the subject. Now, what do you mean by subject? Subject is the server, the person, or maybe any website to whom the certificate has been issued. So, who is the subject in this case? It is facebook.com. Okay. It belongs to Meta Platforms organization and something. Okay. And who has issued this certificate? Now, it is issued by DigiCert using SHA2 High Assurance Server C. Okay. Now, this www.digicert.com is the organization which has issued certificate to the Facebook. So, this is nothing but your CA. Okay. So, this is your CA. CA stands for Certificate Authority. So, DigiCert is the certificate authority who has issued certificate to Facebook. Now, validity is very important. Now, it is issued on 11th May 2023. So, just 2 months back, I guess. And it expires on August 10, 2023. So, next month, not next month, this month. This month, on 10th of August, this certificate is going to expire. Now, whenever the certificate is about to expire, this CA will always send email to the associate, means the responsible person on his email ID. Okay. So it is always good idea to renew the certificate before it gets expired. So it is just like renewing your driving license or maybe passport before it get expired, because once it gets expired, you have to start from scratch, right? You have to do lots of other things as well. So it's always good you just renew it before it is going to get expired. So these are the fingerprints, the hashing algorithm which they have used for it. Okay, so these are the certain things. Now if I go to details, you can see the certificate chain as okay. Now what exactly you mean by certificate chain? This is the chain. Now see, DigiCert High Assurance EV Root CA has given certificate to DigiCert SHA2 High Assurance Server CA, and this server in turn has given the certificate to Facebook. Now I can verify the certificate of these people as well. So I want to see the root CA certificate, right? So I can always go and I can always see the authenticity and especially the public key of the associated with this. So this is the public. This is the public key of that CA. So this CA has given certificate. Now this particular certificate we have just seen this one, right? This is the certificate. Let us see the issuer here. Or on the certificate probably I will see it. Here it is showing me subject is this one, fine. Anyway, I'm not getting the expected something which I was supposed to show you here. But anyway, this is the authenticity. You can always see or cross check this DigiCert high assurance EV root scheme. So this is for Facebook. If I go to Google, let us say, so again, it is showing me connection is secure. If I go to certificate is valid, again, the most important thing for me is its validity. Now see, this is going to expire on October 2, 2023 at this time. Issued on Monday, July 10. Just last week, I guess, this has been issued. Fine. And again, it is issued to google.com. But now who has issued this certificate? It is issued by this CA. And name of the CA is GTS Google Trust Services CA. So Google has already having their own CA, certificate authority. So that CA has issued this certificate to Google. Okay. And because this certificate is here, you can see this padlock. And this website is actually HTTPS. It is using the transport layer security, secure socket layer. Okay. Public key infrastructure is a collection of technologies that are used to apply cryptography principle. Is based on the practical implementation of confidentiality, integrity, non-repetition, and authenticity, and management of trust and relationship. Okay, I want to read all these things, a little bit boring, but yes, it is very important as well. Now, enabling the trust. Prevent rogue systems from integrating between two computers that would like to exchange. So if you are having a certificate, okay, so it is very easy for you to stop that man in the middle attack. Okay, so now what exactly I mean, there could be the attack. Now this is my browser, okay, and I want to communicate with my net bank server. So let us say this is my net banking server, but now this is not the real one. This is the real one, okay, and this is some fake server, but the page looks exactly the same which my bank server is actually having. Okay, but how I'm going to check whether I have connected? There are different ways, definitely, okay, to check whether this is the fake website or the genuine one. But yes, you can use the public key. Okay, so using that certificate, you can validate whether it is the uh, same server or it is the wrong one. So that is used to exchange information. It achieves the public key and validate the identity of the parties. Public key ensures that the trust exists throughout your entire hierarchy and are located in the following. Where are the public keys located? System that is requesting a certificate and system that is offering the service as well. These are the components of your public key infrastructure. Certificate authority is the top in the hierarchy. Okay, so this server is a top in the hierarchy, and maybe this is the person who is requesting the certificate. Okay, this is the entity who is requesting the certificate. To whom? To this CA. Okay, but this request will not directly go to the root CA. So now, if you try to understand what is the network architecture when the CA is there, let us say this is the switch, okay, and these are some computers connected to it. Now this is one server and there is one more server here. Okay, and now it has completely kept in different subnet, and this is different subnet altogether. Okay, now this is your root CA. You never keep this root CA in the same network where your other servers are created. Now, this is something which is subordinate CA. Okay, subordinate CA. Now, what happens? Let us say this is the server, this is the computer who needs certificate. So it will request the certificate, but the request will go to this subordinate CA, and there is a firewall here. Okay, there is a firewall, and what this firewall rule is, it is just accepting traffic from the subordinate CA. Nobody can directly communicate with this root CA. It is just the subordinate CA. So only the traffic from this particular computer will be accepted. So the request will go to this subordinate CA, and on verification, subordinate CA will send that request to the root CA. root CA will issue the public certificate, digital certificate, and then this subordinate CA will send it to the requester. Okay, so this registration server is something which is the subordinate CA. Okay, this is the subordinate CA. Now there is something which is okay, certificate CA, we have seen the authority which is going to issue the certificate. Then we are having the actual certificates. I have shown you how the certificate looks. Then we are having the revocation list. Now what do you mean by revocation list? Revocation list means expiration of the certificate, or cancellation of the certificate before the expiry period. Now I will give you two examples where this revocation list will make some sense. Let us say there is one employee in your company, okay, and that employee is having the certificate. In that certificate, he has been offered with the public key. And what is the purpose of this public key? He can encrypt and decrypt the data, just like we did, right? We had issued the key, symmetric key, maybe for Bob, and he was able to use it for encryption and decryption, right? And the validity is, let us say, 2 year something. 2 year validity is there. So this employee is having the public key, private key. But now that employee has left the organization. Okay, he has left the organization before this time period elapsed. Okay, so he is actually having the valid public key and private key with him. So he can misuse that. Okay, he can misuse that. So now, even though the validity of that certificate is 2 years, the administrators of the company will cancel that certificate before the expiration period, and then it will go to the revocation list. This is one example. Second example, let us say there is one employee, okay, and he is having a doubt that probably his private key got compromised. Okay, he is having a doubt that somebody is using his private key. It got compromised maybe. So then he can request the CA to cancel the certificate even before its expiry period. So that will again go to the revocation list. Registration authorities, I have just told you, these are nothing but the subordinate CAs. Then entities. Entities means they are actually asking for the certificate. Even the verification entity will always be there. And then we are having the certificate templates. So these are just the formats, I will say. So different templates are there for different purposes. For example, what is the use case? My web server requires certificate. What is another use case? My user needs the encryption and decryption certificate. What is the use case? Somebody needs the certificate for digital signatures. Okay, so these are different purposes. So for each purpose, we can have the templates created. Now you can use these template to request the certificate to root CA, and that will go to your subordinate CA, and that will go to your root CA. The root CA will always have a revocation list associated with it. The certificate authority is the entity that delivers the certificate. Certificates are documents that contain information about the certificate issuer, the entity that receives the certificate, that is subject, and the public key. Revocation list are lists that contain certificates that have been invalidated, which means that these certificates cannot be trusted anymore. Registration authorities and entities are organizations or companies that verify request for certificate. If a request is valid, they will tell the certificate authority to provide a certificate. Entities are organizations or companies that are asking for certificates for or verifying that the certificate is not on a revocation list. And certificate templates are models that are used for the different purpose of certificates. Okay. So, okay. Now, what are CAs? Certificate authority. CA issues certificate to entities. It also manages trust relationship. So, the CA will also have his own certificate, or I will say it is the only certificate which is the self-signed certificate. Now, there is no topmost authority other than this CA. Okay. And that's why the certificate, the digital certificate of this CA will be signed by the CA itself. Okay, so this is known as self-signed certificate. But other certificates, those will be signed by this CA. Root CA and subordinate CA. Root CA is top at the hierarchy and initializes it. It stores the root CA keys as well. So see, the root CA certificate holds the root CA's public key and private key. Is isolated and kept offline. As I told you, it is altogether in a different subnet. Okay, it is not connected to the network. Is not directly involved in servicing the entities. There comes subordinate CA. Is also known as registration authority. It verifies and validate entity request and then issues certificate to the entities. Now there are two types of CAs, internal as well as external. Now what are those internal and external CAs? So have you ever seen this very sign? If at all, can you tell me where have you seen this very sign mark? Something in green color like this. Have you seen it somewhere? Just recall whenever you did your transaction on any e-commerce website maybe or your net banking. Have you seen this one? Anybody?
No, ma'am.
You have not seen? Okay. So you should go for this. Let me just go to the Google. Let me check whether at least I can show you the logo. See, this is something we usually check when we go to any transaction. If you are paying your bills, if you are going for net banking. Okay, so now onwards, try to check whether it is showing you this sign. So VeriSign is a third party certificate authority. It is nothing but a certificate authority. It is CA. So you can see such type of certificates are there. If it is not secure, you will see the secure connection fail. You cannot trust this website. Some messages will appear over there. Anyway, so if you are having a certificate, it will be the secure website. Otherwise, it will not be the secure one. And on such website, we usually don't go for any transaction. Okay. So now this VeriSign is a third party CA. Third party CA means this company is actually involved in issuing certificate to other organizations, right? But now when I want to have certificate from this VeriSign, I have to pay for it. It will not be the uh, it will be the costlier option for any organization, right? Now what happens, now just take example of this big organization. Now this organization is having thousands or 10,000s of computers and employees, and most of the employees need the public key and private key for data encryption. Now this organization needs to purchase it from the authorities like VeriSign, even Quart is there if I'm not wrong, even Symantec is there, even Tata TCS is also there, I guess. Okay. Symantec is there. Symantec. Okay. So there are lots of certificate authorities which can issue you certificate. But as I told you, it will be the costlier option. It will be the costlier option. So what organizations do, they can maintain their internal CA. They can have their internal CA. So now this internal CA can issue certificates to the employees. Now, if employee 1 wants to send some encrypted data to employee 2, okay, so in that case, he can use this internal CA's assigned certificate, public key. But now, these certificates cannot be used if this employee wants to communicate with some XYZ organization. Why? because that XYZ organization doesn't recognize your CA, okay, or it is not trusting your CA. It is just like having the degree from any Indian university maybe, and using that degree, you are just searching a job in, let us say, US or UK. So will they recognize this degree? Definitely not. Okay. They will ask you to go for certain examination and their procedures. And once they satisfied, you will get the job or maybe higher education in their country. So they are not trusting the universities in India. But if using this degree, which has been issued by any university in India, if you are searching a job in India, you will not find it difficult, because if that is the reputed university, basically, it will definitely get recognized, right? So this is what I mean by internal as well as external. So now what the company can do, this XYZ company, they can have their own CA, and those CA can issue certificate for the internal operation, okay, their employees. But now if this company wants to communicate with some ABC organization, maybe in that case they will use the certificate from this very site. Okay, so ABC trusts VeriSign, even this XYZ company trusts VeriSign. So there must be a trusted authority which is being trusted by all the organization. So if XYZ organization is communicating with ABC organization with the certificate which is signed by VeriSign, now ABC also trusts VeriSign. Okay, if not, they can always use the public key to verify the authenticity. And this is what the external CA is. Okay, so it is very simple actually. You know what, you must be thinking how to create this CA. Okay, so I'm just little bit going out of the topic, but let me at least show you. If you are not getting this concept, let me show you how this internal CA can be created. So let me just create one server. I will use Windows operating system here. Let me select this. I will show you how that computer becomes certificate authority. That is the only thing I'm going to show you. Means will not take much time. You must be thinking what exactly this CA is, how it issues certificate and so forth. Although not possible for me to show you entirely because I don't have the exact domain and domain name, but at least I can show you how that certificate authority or CA can be created. Okay, I have to wait. Let us not waste that time. Let us just proceed a little bit. I will show you how to create the internal CA. Okay, now what is the difference? Now the internal CA is having the boundary, right? So it is just going to serve a single organization or a company. But external CA is a third party, just like VeriSign, Thwart, Semantic, something. Level of trust only within the organization or company. Okay, so only the employees in your organization will trust the certificate which is issued by that CA, and it is trusted by every entity. Administrative effort, more effort here. Why? Because I will show you. If I want to create my internal CA, I have to create the server, I have to install that service and so forth. Lots of administrative tasks are there. But here you are just requesting the certificate, right? So your administrative effort will be very less here. Additional information, cost is free, because now see, because it is your own CA now, you are not paying for the certificates which you are getting from that internal CA, right? But if it is the external CA, so you cannot get it for free, definitely. Okay, and no direct access is granted. There must be the subordinate CA. Now the certificates. The certificate of this CA will be the self-signed certificate. Okay. But the certificate which this is going to issue some other certificate. Okay. So those will be signed by this CA. So two types of certificates are there, signed by CA and self-signed certificate. So self-signed certificate, let me tell you, it is something you are just signing on your own passport or maybe on your own driving license. Nobody will be going to trust it, right? So this is what the self-signed certificate is. So if you are actually going to any website which is having the self-signed certificate, you will immediately get a message that your connection is not secure. Okay, you will see this message on that website that your connection on this website is not secure. The certificate with public key and corresponding private key can be used for encryption and decryption. When only the public key is used, the certificate establishes trust and performs the encryption. Now, certificate use cases. Where are you going to use those certificate? As we have seen earlier, it can be used for encryption as well as decryption, whether the data is at rest, whether the data is in transit. Okay, so just when secure information gets transferred from one location to another, maybe your credit card, debit card number, your username, password. Okay, so there we use this encryption, but that is through SSL TLS certificate. Again, it is used for code signing, which is nothing but the digital signature, right? So it is used for digital signature as well. Obtaining a certificate. So you first off should have a CA. Okay, so you can send the request to that CA. The CA will receive the request, then the verification will occur, just like if you are requesting for the passport. Okay, so they will ask you, so you usually submit the request, you submit all the required I will say certificates, maybe your birth certificate, your domicile certificate, your nationality certificate, whatever they need. So then the passport authority will verify it. Okay, it will verify it. Some cross check will there. Even the police inquiry will be there. And once it is satisfied, then only you are going to receive your passport, right? So see, verification is very crucial. So even when you request a digital certificate from a CA, that certificate will be having your name onto it. You can now although it is not that much relevant, let me just give you the example. Two people are communicating with each other over the internet. Okay. Maybe they are in meeting. So don't tell me that switch on the camera. Okay, so means in meeting. So now this person is saying I am A and this person is B. A is communicating with B in a meeting. So B wants to make sure whether he is really the person who is saying who he is. Okay, so how merely switching on the camera will not help. Probably B has never seen that person before that. Okay, so there comes your digital certificate. So A can present his digital certificate. Onto that digital certificate, all the details will be there and the public key will be there. Okay, now B will verify whether the person is the same one by sending some message to that person, encrypting with the public key, and he will just wait whether he will be able to decrypt that. Okay, so something like that. And first of all, he will definitely check who has issued this certificate to this user. So if it is the trusted authority, then only the communication will happen. Okay, so this is very important. Okay. AWS Cloud provides their internal certificate authority, which you can interact with by using the AWS Certificate Manager service. So in our AWS, we are having a service known as ACM, Certificate Manager. So provision, manage and deploy SSL TLS certificate. So they are capable of providing you public certificate as well as private certificate as well. I can request the certificate. Okay. So I don't have any domain. Okay. I don't have any domain name, purchase domain name. So otherwise I would have shown you this. So you can request a public certificate and then you have to provide the domain name. Maybe this is demo dot. It will not work definitely, because what will happen, it will just check whether such and such domain is existing and something. Okay, so DNS validation will be there, even email validation will there. I will receive email on this. So once you are having that appropriate information, you can request that certificate. So this CA, after verification, can issue the certificate. This is ACM, AWS Certificate Manager. So the certification is something like this. We have seen it, right? So the expiry date is there, issuer's name, subject's name, and all the details. Revocation list, I have already talked about it. So it will be holding those certificates which are cancelled. Oh, it is always a good idea to see if you are communicating with any particular entity. Okay. So just check whether he is in the revocation list first. If he is not in the revocation list, then you can very well communicate with that person. Okay. Certificates must be securely stored because the certificates are holding the public key and other details as well. So you can use hard disk, encrypted hard disk to store it, smart card verification, and some other ways. ACM service, you can easily provision, manage, and deploy public and private SSL certificate. These certificates are for use with AWS services and your internal connected resources. Okay, so this is just for AWS services. ACM removes the time consuming manual process of purchasing, uploading, and renewing SSL certificate. So use cases is protect and secure your website, protect and secure your internal resources, help you meet some compliance requirement and something. Okay, so now before we go for that KC, let me see whether my server is ready. By the time it must be ready. So this is the password. Let me use it here. I will show you now how the companies create their own CA. Okay. So see, this is my Windows server. I will go to server manager. If you remember, I had shown you DHCP, right? How to create the DHCP server. Now see, if I want to create my certificate server, I will go to this add roles and feature. Just hold on. Okay, now see, I'll click next here. I will add role. And what is the role now? It is on this computer, the local computer of mine. And now I will select this Active Directory Certificate Services. See what I have selected? Active Directory Certificate Service. Let me select this. I want to add all the associated features of that service, and then next. Now, Active Directory Certificate Services provides the certificate infrastructure to enable scenarios such as secure wireless network, virtual private network, internet protocol security, network access point, encrypting file system, as well as smart card login. Okay. So this is what I want to do now. What do you want to install? I just want to install certificate authority onto this. Okay. So this is the topmost server, maybe root server. So I will just install this one and install. Okay. Now it is done. Let me close this one. And now if don't worry if you're not getting this. So I have just selected this role. Or it will be easy for me if I go from here. Tools. And here you will see certificate authority. Let me go from. So anyway, I think I missed something. But this is your CA. Anyway, it is not working. But if I just, if at all it was installed properly, I could have seen the self-signed certificate of this C. Okay, so this will be the self certificate. And then you get the option of requesting the certificate. The entities can request the certificate using various ways, using some links, emails, or some IP addresses of that server and so forth. I think I'm missing it so that I'm not able to show you here. This is the problem with Windows. It becomes so slow. And especially I have used T2.micro here, right? So it is not at all appropriate for Windows. Okay. So let it get installed. By the time what we will do, let us go back to our console. So here we have seen a public key infrastructure. Okay. It defines principles and components that you can use to secure resources by using keys and digital certificate. A digital certificate is an electronic credential that is used to represent the online identity of an individual, computer, or other entity. And CA signs and issues certificate to the entities and manage trust relationship. A digital certificate can be self-signed or signed by a CA. Fine. So now let us go for the KC. So I want everyone now to go for this case. $287 case. Please go for this 287 case. Let us see whether we are able to answer these questions. Okay. What signs and issues certificates to, I think it should be who signs and issues certificate to entities and manage trust and relationship?
First one.
First option. Yes. What is a digital certificate? An electronic credential that is used to represent the identity of an individual, computer, or other entity. So, fourth is the correct answer. Which resource is used with SSL and TLS to establish a secure connection between a client and server? It should be obviously public key and private key, right? So yesterday we have seen how SSL and TLS works. A company's site is giving users an error that the certificate authority is invalid. What could be the cause of this issue? When you get that message, certificate is invalid.
Certificate has expired. First one.
Expired. Yes, certificate has expired. Very good. How is a trust achieved between two parties when using public key infrastructure? Two different parties are there who are going to communicate with each other. So who is going to establish a trust between them?
Second.
Second, by an external certificate authority that validates the identity of the parties. Very good. So with this, we have completed this one. So folks, I want you to watch this video. There is one demonstration here, although you will not get entirely everything. Okay, I think it is 10 or 20 minutes video something. So I want you to go through this as a homework. Okay, so today you are having two activities. It is 9 minutes video. So I want you to go for this video. And secondly, I have already asked you to go for 278 lab and submit me the output, right? Step number 43. I will be waiting for your output. Okay, so again, I will be maintaining it in every participants individual folder. Okay, so lots of data I got from lots of participants previously when we were having Linux. Okay, so in networking, I guess there was no much activities in that case, but again, I want you to go for this one because this lab is very important. Fine. Now I will start with identity and management. So shall we have a break before I start this one? So let's have a 20 minutes break. So it is already 4:45 almost. So we will have a 15 minutes break. You take 5 minutes more for your attendance as well. And then I will start with this identity topic. So it will be easy for you now because it is again your identity IAM service in our AWS. Okay, so now you will again going to come back to our AWS and you will definitely like this topic. Any question? Okay then. So see you after 20 minutes. Thank you. Is everybody there? Please confirm so that I can start.